In this video, we're going to look at another example of using U-substitution to evaluate or to find an antiderivative. The example is to evaluate the integral of 2x divided by x squared plus 4x plus 5 dx. If we try letting u equal to the denominator, so suppose u is equal to x squared plus 4x plus 5, we see that du is equal to 2x plus 4 dx. And we see that in the numerator there is no 4. So we need to add a 4 in the numerator of this rational function for U-substitution to work. But of course we just can't add a 4. That would change the problem. We also have to subtract a 4. So first we write integral of 2x over x squared plus 4x plus 5 dx as integral of 2x plus 4 minus 4 divided by x squared plus 4x plus 5 dx. And then rewrite this as the difference of two integrals. The first one being integral of 2x plus 4 over x squared plus 4x plus 5 dx. Let's call that integral 1 minus 4 times the integral of 1 over x squared plus 4x plus 5. Let's call that integral without the minus 4 integral number 2, and evaluate both integral 1 and 2 and then solve the original problem. So integral 1 we already essentially did at the beginning of the video. We have the integral of 2x plus 4 over x squared plus 4x plus 5 dx. We'll use U-substitution, let u be the denominator. X squared plus 4x plus 5. Du matches exactly with the numerator, which is 2x plus 4 dx. And the integral in variable u becomes the integral of 1 over u du, which is the natural log of absolute value of u. Just a small point here, this is natural log of absolute value of x squared plus 4x plus 5. We see that this polynomial x squared plus 4x plus 5, we can write it in the form ax squared plus bx plus c. So a is 1, b is 4, c is 5. And then we look at the discriminant, b squared minus 4ac, which is 16 minus 4 times 1 times 5, which is negative 4, which is negative. That means this polynomial has no roots and is always positive, and therefore we don't need absolute value. So we can rewrite, say, the integral of 2x plus 4 over x squared plus 4x plus 5 equals natural log of just x squared plus 4x plus 5. We don't need absolute value, but if you kept it, that's fine. It's not wrong. Next, we turn to integral number 2, which is the integral of 1 divided by x squared plus 4x plus 5. And to evaluate this integral, we can no longer let u be the denominator. We're going to complete the square in the denominator. First, we'll write x squared plus 4x plus 5 as x squared plus 4x plus 4 plus 1. X squared plus 4x plus 4 is a perfect square. It is x plus 2 squared. And then add a 1 to that. And now we can make the substitution. Instead of u being the entire denominator, we just let u equal to x plus 2. So du is dx. And the integral becomes 1 over u squared plus 1 du, which is basic. It is arctan of u, or arctan of x plus 2. And we have all pieces now to solve the integral, to evaluate the original integral, which was 2x, integral of 2x over x squared plus 4x plus 5 dx. Remember, we broke it up into an integral, expressed it as a difference of the first integral is 2x plus 4 over x squared plus 4x plus 5 dx minus 4 times the integral of 1 over x squared plus 4x plus 5 dx. And we know the first integral is natural log of x squared plus 4x plus 5, and the second one is minus 4 arctan of x plus 2 plus c.